Hello everybody, what is up? It is Cyborg Elf here with another video, and today we're going to be doing a video going over how to make an ESP for CSGO. This information though is transferable to games like Assault Cube and things such as that. You can transfer this hacking and coding information to other realms, and do keep in mind that this is going to be coded in C++ using GDI, which that is kind of integrated thing. It's called GDI+. I'm not going to do DirectX just because I feel like GDI will be a good starting thing. For a future video we could do DirectX, and you see GDI does have its drawing limitations. Right now you can see a buffering, double buffering going on with the flickering. We'll fix that in a later video. We'll add health indicators and things such as that. And a shout out to Sally, a member of my Discord, who made the base code for this project. We're going to be improving on this base code in later videos. Shout out to him, he's been a long time member. So before we get too into it, if you do not have Counter-Strike set as to launch without VAC enabled, just go to the launch settings and do dash and secure. Essentially this will make sure that Counter-Strike launches without VAC, because this isn't going to be an undetected VAC cheat. It's not too hard to make your cheat undetected, but we're not going to be doing that in this video. We'll be making an ESP. Alright, so I have Visual Studios 2017. 2019 is out. It's been out for a while now, but I haven't updated it. You can get 2019 IDE if you wish. It's the same thing essentially. And what we're going to be coding in is C++. So just create a new C++ Windows console application. I'll name this tutorial ESP, and I'll save it to my desktop. Now the code for all this will be on my website. There'll be a link to my website down below if you want to go check out all this code. Let's get into it. I'll be coding kind of fast, and I'll be copy and pasting a lot of functions that I've already made into this. So let's get started with the includes. We'll be using two other includes. Make sure you do the Windows include on top of TLHelp32 include, else it might cause some errors. Now this Windows include is basically allows us to access the read and write functions that the Windows API has. It's really useful. In this TLHelp32 include, I'm saying include, they're really preprocessor directive. This TLHelp32 include allows us to get all the running processes and modules on our computer, so we can find the ESP module that we're going to read and write to. If this is complex, I have tutorial videos that I'll have linked down in the description. I recommend you watch that first if you're confused by this. I'm going to be going through this kind of fast. So we're going to be making a header for our offsets. I like to just do this just to make everything simpler. So we'll make a header, we'll name it offsets, and we'll include our offsets that we're using. Right here is them, the entity list, view matrix, the team, the health, and the vector origin. Now if you don't know where to get offsets from, games like CSGO definitely have like a public database of up-to-date offsets. Haze Dumper is a big one for that. So let's actually head back over to our source, and we'll include this. So hashtag include offsets. Now let's get rid of this, and let's actually drag in some global variables. So this define, we're going to be defining enemy pin. In a later video we'll actually make a friendly pin, as you see in the intro how I had both red boxes and green boxes. This enemy pin is right here, and this hexadecimal number is red, and same thing with this. I'll show you how to change the color if you want to have your own unique color. We're just defining the brush using GDI, which is built into the C++. If you do not know what GDI is, there's lots of documentation. Oh, right here, there's lots of documentation. It's just a graphics interface that allows you to write graphics really easily for C++ applications. At least for GDI Plus is kind of the integrated GDI with C++. And we will, right here is what I was talking about with the GDI double buffering. If you want to read this and fix it yourself, you can, but we'll fix it in a later video. Now for color picking, you can select a color. You can use websites like this. Just literally search up color picker, and you can find something cool. You know, choose a cool color design you like. But you just paste that in here. Make sure you include the hexadecimal identifier, which is 0x, else your computer will freak out. And yeah, choose a cool color. Feel free to customize with that. Okay, next we're going to be getting the screen X and screen Y of our display, and this is actually like the length and the width of the screen. So we're just getting the system data of the X, which is across this way, and the Y, which is up that way, like a graph is. Now these two functions I'll copy and paste in here, because this right here is the get process ID function. We've used this previously a lot, and actually some other tutorials. This is what we're going to use as a function to get the process ID. And like I said, the code will actually be down in the description on my website. I'll do a quick scroll through in case any of you want to type it line by line. Right there's that. And now there's another function we're going to be used to get the module base address right here. So I'll paste this in here. And here's the function right here to get the module. Alright, now let's define some more globals. So right here, this is a uint pointer, which is just a x86 and x64 variable essentially. So we're defining our module base as the process. So we're getting the process ID of CSGO. You can do this in two separate ones, but he was really efficient by putting this in just one line. So we're getting the process ID of CSGO, and within that process ID, we're grabbing the module of the client underscore panorama DLL. CSGO is one of the games that's kind of weird and has different DLLs that kind of run in the game that you have to access manually. It's really the only one that I've seen that does it like that, but it's interesting. Okay, in this next line, we're actually opening a handle. Handle you can think of as a tunnel of communication where we communicate with the application. So this all access defined right here is saying that we have the ability to, giving ourselves the ability to read and write to the application, the process CSGO. Sorry if I'm speeding through this. I really haven't had a lot of time to do these videos, just with school and stuff, but I wanted to get that video out for you because you've all been dying for an ESP video. So we're just, for this, we're getting the window Counter-Strike global offense, and right here actually what I'm about to paste in is a nice little template class that Sally made. I don't know if he made this or if he got it from somewhere else, but right here it's essentially making a template. It's an easier way to input variables to get a required result, and you'll see this later. So right here we're gonna make a struct, which is a fancy class essentially for the view matrix. The view matrix is a 4x4 array. Actually, I think we can probably find a image online. Let's just do view matrix is a great example. You have the first three, the left axis, the y-axis, and the z-axis, and you have the translation. So you can just see a 4x4 array where everything is stored. So we made a struct for the view matrix, and we'll be implementing these to save our different things. And this next struct is pretty simple. This is going to be a vector 3, so the x, y, and z, just to store the positions of the different players. And now this next function, I'll do some explaining because this is really the only calculations that we'll be doing for this whole video. For aimbot, it's a little more calculations, but this is kind of at the core of it. The roll to screen function, you probably heard this before, and looking past this code you can read through this and try to understand all the math. It's not too complicated if you want to take the time and look through it, but luckily for you I have found a nice little blog post on this that someone did, and in essence what this does, it turns 3D points. So your game and the computer sees things as 3D, and you turn this 3D into 2D because your screen is physically 2D and it's emulating a 3D environment. It's kind of trippy, and what this does is it turns the 3D environment into a 2D environment that your screen is, because your screen is flat, just logically speaking. Now for the next functions, we have the draw filled rectangle, which is just gonna draw the rectangle for our ESP. Sorry, I'm pretty tired. Just pasting these in pretty fast. This is just the whole GDI overlay things, and GDI is pretty simple. I'm seeing through this because if you're interested in looking at all the GDI things, you know, you can do text, you can do a lot in GDI. Just simply like search up GDI plus, you know, how to draw a line, how to do this, how to do that. So we have these two functions right here. This function is going to be the draw line function, and we can actually see where we're using the colors that we have defined. Enemy brush is the color right here that we have defined to draw the rectangle, and then right here we have the enemy pin, which is the pin that we have defined to draw the pins for the lines. Okay, now that we have all, we haven't even gotten into the main code yet, but now that we have all this defined and all of it's looking good, we can get into our main. So we'll do a while true, just so this is always running and always checking. We will actually do our view matrix first, And we're going to be using the structure we made up here, which is the 4x4 kind of array. So we have our view matrix, and we'll just name this VM. And now here's where this class that Sally made that's going to come in handy. So we can actually just input our information like this, like view matrix, and then we set view matrix to be saved as the module base, which we already defined above if you do remember. Right here, module base. And then we'll just add the view matrix offset, which we already defined in our offsets header, which we linked our offsets header in the preprocessor directive. Now we can end this line with a semicolon. Now we can get our local team. And the reason we're going to get our local team is just so for this first part we're only going to be drawing boxes to the enemies. So we'll do, oops, sorry, no space, local team is equal, then we'll use this template again. And now we're going to be doing a read within a read. So we'll be doing another template and a template for the reading process memory. And with what's in these two pointy brackets are what we're saving it as. So for this first one we'll be saving it as an int, and this next one we'll be saving it as a D word. And these are different storage types, and so like, you know, we obviously need to store the view matrix in a 4x4. The local team is going to be a, I believe for CSGO it's a 1 or 2 value, so I'll store that as an int, and we are going to store the module base plus any list as a D word. So we'll do module base plus entity list, DW entity list, and then we will add the team number, and boom, that line is done. Okay, so next we're going to do a for loop to cycle through every single player in the game. So we'll do for, and then we'll define an int as I and set that to 1 because we don't want to draw to ourselves. And then we will do this out of 64. So I believe that's the max number of players you can have in a CSGO game, 32 versus 32. And then we'll just add an increment right there. Now this line right here that I just put in, we're defining the player int, the player entity that we're going to be looking at. So we cycle through each one and we look at different player entities at once. So we're getting the first player entity. So I is the global, it's not the global, it's the local scope variable right here. So, you know, I will be 1, and then we'll be looking at player 1 because I right here. And the distance in between each player is 10 hexadecimal. It's an offset of 10 in between each characters. So the first run of this we'll be looking at player 1 because I is equal to 1. The second run I will be equal to 2, and we'll be looking at player 2. I hope that makes sense because this is a kind of a core thing when you're scrolling through different players. This is just going through each different player, and it puts the number, you know, 1 times this. We're looking at that player. We're looking at the second player on the third run, the third player on the third run, the fourth player on the fourth run, the fifth player, and so on and so forth. And the distance for most games is 10, offset of 10. If you don't know the distance for your game, you can look at a program like reclass.net and find the distance. Okay, for the next things that we're going to be defining, we'll define the health. We'll just read the entity, the player we're currently looking at, and we'll get their health. The reason we're doing this is just so we don't draw our boxes to any dead players. And the next thing, we'll get our team, the team, and we'll say that as an integer so we don't draw boxes to our team, and we know what color for the future video, we know what color to draw the boxes to. So this next one, we're actually gonna use the vector3 structure that we made up here, right here, and where we save values as x, y, and z, because that is the that's where the positions of the players are in game. So we'll get the x, y, z of every single players, and we'll save that as that. And next we'll get the head, and we'll save that as a vector3 as well. So for this next one, we'll do a vector3 as well, and we are going to get we're going to be using this world to screen function that I talked about. So we're going to be turning the two variables that this takes, it's going to take the position, the x, y, and z, and the view matrix, and it's going to turn that into a 2D, so we know where to draw the boxes on our screen. So right here, we were previously dealing with a 3D information, and now we're going to be dealing with 2D information because we've done the world to screen function. And we can do the same thing for the player's head. And we're going to need both these so we can draw the boxes. So with these two informations, we can get the height of the player. So we just subtract the head of the player from the position of the player, and then we get the height of the player. And then for the width of the player, we divide the height by the magic number of 2.4. F means it's a float for both this and this. And now we actually have our if function. So right here we get if the screen position is greater than 0. So if it exists essentially, and the team is not the local teammate, so if it's not one of your teammates, and the person's health is greater than 0, so if the person's alive, and the health is less than 101, so if the person's not spectating or the such, you're going to draw the box with this right here, and then this will draw the kind of ray line to the person. So this all looks good. Let's actually save this, and we're going to be compiling this as 32-bit, so x86. And yeah, okay, let's actually let's launch up our game, and then I'll run it. Now make sure you are in windowed for this, because we're getting the not in windowed, sorry, in full screen windowed, or full screen, your choice, because we are getting the dimensions of the screen, not the window. And if you get any errors when you're trying to run this, make sure you actually do run this as an admin and you build it if you don't have administrative privileges on your computer. So I will debug it, and it's loading. And here we go. So we have the GDI boxes being drawn. And we still have issues with this, like this person is still alive because they haven't, or the box is still drawn because they haven't respawned yet, or an issue like that. We'll look into this in a later video, we'll improve on it. Even in a future video we could do something like 3D boxes. Anyways, if you did enjoy the video, if you haven't seen any of my videos before, I recommend you subscribe and check those out. Peace out.